everybody. Welcome to our webinar today on heat pump water heaters, the lowest cost, lowest carbon hot water. I'm Joe Wachunas with you with Brian Stewart, my teammate as always from Electrify Now. We'll introduce our panelists in just a second. Today's webinar is being brought to you by Electrify Now, which is an all-volunteer organization promoting electrification as the quickest path to decarbonization. It's something we can all take part in. You can get tips to electrify every part of your home at our site at electrifynow.net. It's also being brought to you by the LEARN program, which is a San Diego-based workforce and education and training program that has partnered with Electrify Now to offer these free energy efficiency and electrification webinars. Please visit the LEARN website for more information, www.sandiego.learn. Great. Well, so today this webinar is part of our Go Electric webinar series, talking about the benefits of electrification for homeowners, which of course include lower energy bills. We'll see that today, cleaner indoor air, lower pollution outside, more comfort, and increased safety. And why are we focusing so much today and this week on hot water? Well, a lot of folks don't think about their water heater, but it's the second highest energy user in the home. Up to 20% of home energy use is used for heating water, so that's a lot. And new heat pump water heaters are extremely efficient. We'll see that in just a second illustrated. So today we're going to talk about what heat pump water heaters are. It'll be a heat pump water heater 101 for us all. How do they compare to other water heating technologies? And what do you need to know to get one installed in your home if you're on your heat pump water heater journey? Okay, so to illustrate some of these points, the big three as far as carbon emissions in most of our lives are our water heater. This might be a surprise, which is 1 to 3 tons of CO2 annually emitted, and your gas furnace and a gas car. So look at 4 to 8 tons for each of those. So those are the big three. If we can tackle those big three, then we are well on our way to decarbonization. And so we'll talk about the water heater today. Now, heat pump water heaters are an energy efficient choice for water heating. They're 3 to 5 times more efficient. They've been out since 2009, but it's an old technology that is used in refrigerators. Basically, it's a compressor on top of an electric water heater tank. And that compressor just harvests air from the surrounding space that the water heater is in and concentrates that air into refrigerant coils and wraps around a tank and transfers that heat to the water tank. It doesn't exhaust any pollution, just cool air. And so heat pump water heaters need some air to breathe. We'll talk about that in just a second. But they don't exhaust anything like NOx or any of those other pollutants that fossil fuel water heaters do. Now, there are some split heat pump water heaters where the compressor is located outdoors and the tank is indoors usually. We're not going to get into those too much today, but they do exist. Great, so this just gives you a little lay of the land for the type of water heaters that are out there typically. On your left, you have electric storage, and then you have 3 types of fossil fuel water heaters, propane and gas, and then you have heat pump on the right. Now, if you want to, water heating efficiency is measured in UEF, which is how much energy you put into the water, how much energy you get out. And as you can see, the UEF for heat pump water heaters is 3 to 5 times more than the other types of water heaters. A lot of folks think that, oh, your gas tankless water heater is going to be the most efficient because it doesn't have that storage tank of water. No, heat pump water heater is still almost 4 times more efficient than the best gas tankless water heater. And the upfront costs for these different water heaters can vary. Some of the older storage tanks can be a little cheaper with that upfront cost. And heat pump water heaters are typically between $1,500 and $2,500. That's kind of comparable to the gas tankless water heaters. But look at the operating costs for these for this equipment. You can see the heat pump water heaters are by far the lowest cost option in pretty much every part of the country. You're going to pay between $100 to $200 a year to heat all the water your family uses. And other water heating types are 3 to 5 times that amount. And of course, the carbon emissions follow suit. Heat pump water heaters have a minuscule 0.4 tons of CO2 emitted a year. And if you have access to renewable energy or subscribe to community solar, you can bring those carbon emissions down to 0. Let's just talk about a little bit what you need. Like we talked about before, you need some airspace for that heat pump water heater to breathe, to pull that warmth out of the water heater. And so depending on the manufacturer, they recommend between 400 and 700 cubic feet of air for your water heater to breathe. So if you have your water heater located in a garage or a basement, that's typically more than enough air. If you're like me and you have your water heater located on a utility closet, there are still other strategies. You can have a louvered door that allows air to enter into that utility closet, or you can put in wall grates. My wife and I just did this in our home, and we have wall grates that lead right behind the fridge. It's a perfect marriage between those two technologies because those fridge exhausts warm air. In some cases where you just don't have enough airspace, you can duct a heat pump water heater, but there's usually other options so you don't have to duct that cool air out of the space. Most heat pump water heaters, you're going to want a dedicated 240 amp circuit, a 240 volt, circuit. We're going to talk about ones that are plug-in 120 volt heat pump water heaters. But you're going to want that circuit. So if you have an electric water heater that you're replacing electric resistance, you already have that electricity on site. If you have a fossil fuel power water heater, you're going to want to maybe run a new electrical line. And then the one thing you're going to have to think about for heat pump water heaters, just like a lot of appliances like gas furnaces, you'll have to dispose of this condensation. It's not acidic like with fossil fuel appliances where they have acidic condensate, but you do have some a water that's produced usually between 1 and 2 liters a day that has to be run either to a floor drain or your laundry drain, or if you don't have any of those options, usually you can get a condensate pump that pumps it away from the water heater.
Great. Well, so as Joe said, if currently you have an electric water heater, then replacing that with a heat pump water heater is pretty straightforward. It's essentially a 1-for-1 replacement. Those space options or space considerations we talked about, so you've got enough room for it to breathe is important. They typically are a little bit taller than conventional water heaters, but for the most part, you're literally unplugging the old one and plugging the new one in. If you have a gas water heater, however, it's a slightly more complicated situation because you're not going to have that dedicated 240 volt circuit there unless in some situations people had electric water heaters and they replaced them with gas and now they're going back to electric. If you're in that situation, you're fortunate because you probably already have the circuit, but most people are going to need a new 240 volt circuit run from their panel to the location where your water heater is. And that most of the time that's the way to go, but there are situations where that can be expensive. It might trigger a panel upgrade or other electrical costs that can be expensive. And that's why this product that's called the 120 volt heat pump water heater is so exciting. We'll talk more about this in a minute, and we'll talk about this in depth with our panelist who's got a lot of experience putting these in. But essentially these 120 volt circuit models were designed specifically for gas water heater replacements where it's going to be difficult or expensive to put in a dedicated circuit. So how do the two things compare, the 240 versus the 120? They're essentially the same technology on the inside. All the heat pump part of it is essentially the same, and that's the magic part. But what's different between these two are the 240 volt ones also have electric resistance heat. That's why they're often referred to as hybrid models. And so they have the ability to act like an electric resistance water heater, whereas the 120 volt models don't have that. So they're relying on the heat pump only to heat the water. But there's some advantages. Like we said, you're able to use a 120 volt existing circuit, and it can even be a shared circuit. It doesn't even have to be dedicated. So with the 241, you're using the existing one or putting in a new one. With the existing 240 volt line. With a 120 volt, you can use an existing, whatever the gas water heater was using before, because most likely it needed 120 volts for either the fan or the condensate pump or something, or there's likely to be one nearby. The 120 volt models are slightly less energy efficient, but they're still way more energy efficient than anything else out there. So that's not really a concern. They have a slightly lower first hour rating, which means this is how much water if your water heater is fully charged up and it's been, purring away in your basement all night, let's say, and then the next morning you want to take a shower, you're going to get 55 gallons in the first hour of hot water versus 67 for the 240 volt. But the bigger issue may be that the recovery rate is slower. So for the 240 volts, these are operating essentially exactly like, or they can operate just like an electric resistance model if they get forced into that backup kind of electric resistance mode. The heat pump ones don't have that. So you're going to be slower to reheat the tank. There are things like mixing valves, which we'll talk more about, that are pretty much standard on these 120 volt models, which helps to give you more hot water by increasing the temperature in the tank, and then it mixes cold water as it comes out of the tank, which gives you a lot more hot water. So we'll talk more about how that affects performance. But for the most part, if the 240 volt ones are perfect for replacing existing electric water heaters, and it's the best way to go if wiring isn't difficult. If you use a lot of hot water, you might want to size up, but we hear a lot, and that's certainly our case in our house, that if you've got an existing 50-gallon electric water heater, you can go with a 50-gallon 240 volt heat pump, and most likely you're going to be fine. If you're experiencing water problems, you might want to upgrade to a larger size. But for the 120 volt models, it's often recommended to go one model size up, a little bit bigger tank to get more hot water. All right. So in terms of the manufacturers, there are more and more manufacturers all the time. Rheem, A.O. Smith, and Bradford White were sort of first ones to really get serious about this technology. But there are many more players out there and more coming in all the time. We're going to be talking about that tomorrow in a webinar dedicated to that exact topic. You can see the Sanco is an example of the split system over on the right, but the others are more just essentially like conventional units. They don't really have dramatic differences in terms of their performance rating or cost to operate. They're very similar. So I would say that our recommendation would be that if the most important thing is to find a good installer who's got a lot of experience installing these, and then see what they say. They most likely have a recommendation because it's something that they're familiar with. They've got experience servicing it or whatever it is. And oftentimes that's more important than trying to choose a model based on one of these differences in specs. By the way, they all have 10-year warranties, which is really important. That just means that they stand behind their products. And just to put that in perspective, like typical gas and electric water heaters have 5 or 6-year warranties. So it's saying something that they are confident that their products are going to perform. All right, let's talk quickly about incentives. There's federal tax credits, which you're probably aware of through the IRA, the Inflation Reduction Act, and you can get 30% of the installation cost up to $2,000. And so you might not get all that $2,000 because 30%, it depends on how expensive your install costs were, though. In some cases you might, but in some cases you might not get all of that, but you're still going to get a chunk of money from the feds. There are rebates also coming from the IRA program that are going to come with income qualifications. So you have to be either low or median area income in order to qualify for these. It really varies state by state. They're just starting to roll out. I think New York has theirs going now, but most states aren't going to get theirs going until probably mid to late next year or even 2026. There's a lot of program work that they're doing to figure out how to use this money from the federal government. But there are also existing state and utility rebates that are out there right now that can save you hundreds of dollars. Here are just a few of them that we're aware of. You can look at the Energy Star rebate finder, energystar.gov/rebate finder. We'll put that link in the chat. And you can check out what's available in your area, but you can see that these range from like the low of $350 up to as high as $2,300 rebates. So it really can be a good way to lower the costs and essentially make them a similar, or in some cases even less expensive than to install than those conventional technologies we talked about. So it's exciting what's happening. If you look at sales, this is a relatively new product in the market. Most people aren't familiar with these. So there's a lot of just education that's happening and awareness that's happening, but you can see the growth is pretty quick. But there's still a long ways to go in order for them to be comparable with the other kinds of water heaters that are being sold in the millions. But what's also happening that's going to really increase the speed of adoption here is that the federal standards for efficiency are changing starting in 2029, which means that for electric water heaters, this heat pump technology is going to be required for anything over 35 gallons. So that's been essentially going to mean that starting in 2029, you won't be able to buy a standard electric resistance water heater. It's going to push people into these dramatically more energy efficient models. So we have some great resources for you. We'll put the links here in the chat. Of course, Electrify now has a lot of information about the technology, the incentives, information about installers, et cetera, for the Oregon area and locally in Portland where we are. We also have the Switches On, which is an excellent resource in California and starting to be better and better in Washington as they move into that state that has great information about the product, incentives, and how to find good contractors. And then if you're outside of those areas, Rewiring America is a great resource. They have a contractor finder that will help you to find someone that's got experience with this product in your area. Okay, this is time to introduce our panelists. We're really excited to have Tristan Dennis with us from Barnett Plumbing. He's a project manager for Barnett, and he's managed over 500 heat pump water heater installations, which gives him that's a high bar because this is relatively new technology, like we mentioned. So there are probably not that many firms out there that have installed this many. So he's got a lot of experience with this, and he works with the contractors and homeowners to educate them on the benefits of heat pump water heaters, make sure that all the products are inspected for final installation permits. And he also works with local and state programs to make sure that these installation programs and application processes are as streamlined as possible. So he's got a lot of varied experience, and we're really excited to have him with us today. So welcome, Tristan. Really glad you could join us.
Thanks, Brian. Excited to be here.
And
why
Brian,
not?
we're still
Maybe,
seeing your slides, Brian.
Oh, is that right? Sorry. I'm sorry. There we go. Yeah, Tristan, why don't we start by why don't you tell us a little bit about Barnett and just a little bit more about what you do there and the experience you guys have had specifically with heat pump water heaters, and yeah.
Yeah, sure. Like Brian said, my name's Tristan. I work with Barnett Plumbing and Water Heaters. We've been around since 2005, so we're actually just about to hit our 20th birthday. We are located in the San Francisco Bay Area, and we've been installing heat pump water heaters for a few years now, and have participated in a lot of the incentive programs that have come through over the last few years. Which this last year is actually when I came on, and we installed over 500 heat pump water heaters. So we do have quite a lot of experience with them, and we found them to be a really great option for homeowners in the area.
Awesome. So maybe you can talk to us about the top things that you think a homeowner should consider when getting ready for a heat pump water heater installation. You know, we talked about some of them: location, their water heater type. But yeah, what are your top considerations when somebody's starting on their heat pump water heater journey?
Yeah, absolutely. So one of them, like you said, location is a big one. At Barnett, we actually we typically upsize the water heater whenever we're switching to a heat pump. So we always make sure that there's at least a bit more space. One other thing that we want to make sure that homeowners take into consideration is they are a bit noisier, especially if you're going from a gas or electric water heater. So if they are up against a bedroom wall or something like that, we might suggest relocating. There's almost always a place to relocate it to, so that's usually not an issue, but it's just something to take into consideration. Also, making sure that you have enough airspace. Like you guys had said earlier, it's super important to make sure that you have the correct amount of airspace that the manufacturer recommends so that the heat pump technology works correctly. Condensation lines, you do want to make sure you have a termination point for those. You definitely have to have somewhere for that water to go to. Like Joe said, it is not acidic, so it's in every building department we've worked with, it's even fine to run it to the outside of the home if you don't necessarily have a drain nearby. And then also just to keep in mind that since the recovery rate is lower, just to pay attention to your usage rate and maybe consider upsizing, maybe depending on how much your household uses or how many bathrooms you have.
Yeah, well, maybe since we are there on the upsizing conversation, maybe we should just jump into that. We got lots of good questions, and by the way, please put your questions in the Q&A. We'll try to make sure we answer them. Yeah, so I've heard differing things, and I think part of the I think let me just explain a little bit about remind people about the 240 volt ones. Let's start with the 240 volt.
Sure, yeah.
Because they have this ability to work in two modes, basically electric resistance mode and heat pump mode. The truth is you want to avoid using electric resistance as much as possible. In fact, we have ours put on heat pump only mode, which means that it won't turn the electric resistance strips on, which means that it's going to heat water more slowly for that recovery time. But I've heard varying things about, the need for upsizing. We didn't do that in our house. We had a 50-gallon gas, really a Provent model. And on the noise side, actually, our heat pump water heater is less noisy than that was. But we didn't upsize. We haven't had problems. We've had 3, children with us and made it work. It wasn't really an issue. We have low flow shower heads and that sort of thing, which I'm sure is part of it. But I think if you use a lot of water, hot water, you might be triggering that resistance mode more often, which is, I guess, one of the advantages of upsizing. Is that right?
Yeah, exactly. So we want to make sure that our customers see as much savings as possible. So that's part of the reason for upsizing. Like you said, I mean, we have had homeowners who really wanted to just go same size water heater. And in those cases, it is most of the time worked. It's just we've had some cases where it didn't. They didn't take into account their usage very well. And so it just kind of on the safe side, we like to size it up at least once with the 240 volt, like you said, and we actually go sometimes 2 sizes up with the 120 volts, since the recovery, there's no chance for the recovery rate to be increased with the
right
heating elements.
So one strategy is to upsize the tank to get a little bit more hot water. Another interesting strategy, right, is to do a mixing valve. So for folks who are not familiar with water heater jargon, mixing valve is a valve that will allow you to heat your water heater to a higher temperature. Typically, water heaters come factory set at 120 degrees, but you can heat it up to 130, 140 degrees. That gets hot. And so the mixing valve mixes in cold water so that you don't get scalded. Tristan, talk about when mixing valves are a good idea, and tell us a little bit about Barnett's approach to using mixing valves.
Yeah, so I'm glad you brought that up. So we actually always include a mixing valve with our installations. We want there to be as much efficiency as possible when installing these water heaters. And so, like you said, it just allows us to set the temperature to be always at 140 degrees Fahrenheit. And that way, whenever the homeowner calls for hot water, it's not using only hot water from the tank. It's also pulling a little bit of cold to bring down the temperature to the actual desired temperature of usually 120 degrees Fahrenheit.
So you get that extra water heater. I've heard manufacturers, or we heard actually yesterday in our DIY install, that for every 10 degrees above, you get almost like as if you have 10 more gallons of hot water. Is that?
That sounds right. I'm not sure of the exact numbers, but that does sound correct.
Yeah. Yeah, that sounds good. I mean, I was talking to the Efficiency Maine folks the other day, and they've installed, they've installed 70,000 of these in Maine, which is fantastic. It's like,
that's huge.
they're ahead of the curve there, and because they've got really good programs that make it really cost effective for homeowners. They mostly install 50 gallons. They said that one of the things they do is they recommend people turn their water heater up to 125, 130, even without a mixing valve. You got to be a little careful because it's going to be hotter. 130, I don't think it's quite scalding, but it's hot. So you got to be a little bit careful. But and then use those low flow fixtures and that sort of thing to and they say most of the time that works. But I think it really depends a lot on just how much hot water you use. So but I think there's strategies both ways. It sounds like some of the manufacturers, Joe, isn't this correct, are thinking about including mixing valves standard in some of these units.
Yeah, we're excited about that. I don't know if you're Tristan, but a couple of models coming out will have mixing valves integrated into the water heater, and I know already the 120 volt plug-in models have
Mhm.
integrated mixing valves. Is that
Right, yeah, the 120 volts do, and then we just add on for the 240s.
got it? It'd be nice. I think in the future we'll see integrated mixing valves even in the 240s, which would be great for folks.
That would be awesome, yeah.
Yeah.
Hey, Tristan, just in terms of installation, so if you were installing a heat pump water heater versus an electric resistance water heater, say someone already has an electric resistance water heater,
Mhm.
they want to go to upgrade to a heat pump. Is the installation cost different than that if you were just putting in another resistance water heater, or is it similar?
So compared to a resistance, so it is a bit higher just because, for instance, we need to run the condensate line out, and then and then the tank itself costs more typically.
Right.
And then you also want to again take into consideration any space requirements. So say it's in a closet, we might have to install louvers or special ducting for it to work right. And then the only other thing to consider would be if it has side connections. So a lot of heat pump water heaters have different connections for the water lines, whereas most electric resistance, the water lines come in through the top of the water heater. A lot of the heat pumps come in through the side, so it costs a little extra to the extra work and the extra copper for that.
Gotcha.
Yeah,
Yeah.
I'm excited. So I think some new heat pump water heater models have those connections at the top.
Yeah,
So that'll make life easier.
that's new. Yeah.
Lots of nice
Yeah.
improvements coming in with later models. We're getting a lot of great questions in the Q&A. Someone is asking about condensate pumps. Can you tell us, they're wondering, do you have to have a condensate pump for all installations? Tell us about how Barnett usually runs the condensate line.
Yeah, so you don't need them for all installations. We only use them whenever we need to go against grade. We usually try to have them downgrade out of the home or to a drain. So what we'll do is the little flexible plastic pipe that's attached to the water heater will transition into hard PVC pipe. And then we'll run it like we would, like you would with an HVAC. A lot of building departments actually allow you to tie it into the HVAC condensate line, so that you don't need more than one termination point. But yeah, we'll run it to that and then try and downgrade it out. If it needs to go up and out, like say through a basement or something like that, that's when we would use the pump.
Gotcha.
Great.
And then another question, Danita's asking about, her gas water here has to be on a stand. I think that has something to do with ventilation and vapor or something like that. But
correct.
do heat pump water heaters need to be on a stand?
They do not. At least in California, the only thing to consider is that if you put it on the floor in a garage and it's in the way of a vehicle, sometimes that stands, when you drop to the floor, you'll need to install a bollard, like a protection pole. But if it's on a stand, usually it's not required. So you just, in terms of the functionality though, no, it's totally fine to drop it to the floor.
Great. This question is, I think, asked a lot. Talk to us about recirculation pumps. Someone's asking if they have one with a timer. Some folks have these recirc pumps that recirculate hot water in their pipes all the time. So when you open your faucet, you instantly get that hot water out. They're also very wasteful because you're constantly like heating that water in your lines. What works best for heat pump water? Because there are some considerations with recirc pumps.
Yeah, for sure. I'm glad you brought that up, actually. So with recirculation pumps, there are actually new pumps on the market that are specifically designed for heat pump water heaters. The issue we found with your typical either timer or auto adapt feature recirculation pumps is that they would pump lukewarm water into the tank, and the sensors in the heat pump water heater tanks weren't able to determine whether it should heat up or not. So either we would have homeowners getting cold water, or the heat pump backup heating elements in a hybrid would run more than they were actually needing to. And so there's these newer models that are called on-demand recirculation pumps that basically either have a motion sensor or a push button. So you walk into your bathroom and you either press a button or the motion sensor sees you pass by, and it'll trigger the pump to start running so that in a few minutes, you don't need to have your faucet running or anything. And then in a few minutes, you should be able to turn it on and have that instant hot water.
Gotcha.
Great.
Hey, we talked a little bit about ducting, and I know there's some questions in the Q&A and chat about that. How often do you find you have to do that, and how difficult is it? I'm sure it's kind of a little hard to answer that question because every house is a little bit different. But what would you say generally about ducting?
So we haven't had to do a lot of ducting just because, at least we're in our location, most water heaters are located in the garage. If they're in an outside closet, we'll just install louvers, and that is more than enough. So we have done it on a couple homes, though. In that case, we subcontract for an HVAC company to come out and basically let us know what needs to be done. And then we'll have them usually come out after we install the heat pump water heater. And then in the interim, we'll just like leave the door open or something like that to give it the airflow. But I definitely would make sure you have the airflow. We have had customers in the past where we didn't install the right size louvers, and that actually did cause the heat pump to show error codes. And so it was easily fixed by increasing the airflow to the area.
Gotcha.
I would put in a plug for also louvered doors. I mean, I think ducting is considered maybe the option of last resort.
Yeah.
You really don't have that airspace. For a long time, just speaking personally, we ducted our water heater to our attic, and it works fine. But and just doing a remodel this year, we put in some wall grates, as I mentioned before, that lead right behind my fridge. And you can get that passive air transfer into another room. If you can dump it into the kitchen, I saw somebody mention the bathroom. Those are hot areas, and you can. That's great. You can pull the heat from those areas, and that seems to work well. Do you guys ever do wall grates, Tristan, between rooms, or anything creative on that end? Or it's mostly garages, I think you said.
Yeah, and we usually just use the doors, if anything.
Got it. Great.
Yeah, while we're talking about this temperature thing, so these devices do cool the space they're in slightly. I mean, we talked about it, but maybe we should go into that a little bit more. Like, for instance, we have ours in the basement. It's a unfinished basement. It's not a conditioned space, but because it's underground, it's almost always like 55 degrees or something down there, between 55 and 60 degrees. I think it does. I think when we first put it in, it felt like it lowered the temperature maybe a degree or something like that in our space. It dehumidified, which was really nice because it got rid of a lot of the kind of mildew problems that we had down there. But what you don't want to put it in a space that you're like spending a lot of time in. But what would you say just about that temperature decrease that you're going to get in the space, Tristan? How do you advise homeowners on that?
Yeah, so we recommend against putting them in, say, if you have a converted garage, we wouldn't have it in the same space that you're sleeping in unless you want that cool air. Which, we did actually have a customer recently who specifically wanted to duct it to a certain room in the house to cool down that room. And so there's a way to kind of use that as a benefit rather than a drawback. Kind of like you said with the dehumidification. And so, yeah, but it's not super noticeable. It just depends on the area it's in and what the use of that room is.
Yeah, that sounds great. Again, speaking from experience, we have ours in a utility closet. It gets a little cooler when it's running, those 6 to 8 hours, but most of the time it's not very noticeable. And in the summer, it's a benefit. We've gotten a couple questions on like, what's the minimum ambient temperature required for the heat pump water heater? What's the temperature range that they can operate in? And what happens, say, if it probably wouldn't happen very often, but if it falls below that temperature range or potentially above that?
Yeah, you know what? Let me pull that up because I don't remember off the top of my head. I believe it's a little different depending on the manufacturer. But I know that we've never had a water heater or a heat pump get too cold. Now we are in the San Francisco Bay Area, so we don't get freezing temperatures. If you do, I would just recommend going with an electric, or sorry, not electric resistance, going with the hybrid that has the backup heating elements, because if the heat pump gets too cold, then you have the backup heating elements so that you never run out of hot water.
Yeah, I know a lot of the manufacturers say, in fact, I was just looking at Bradford White. They had this, 10 myths about heat pump water heaters. And one was that you can't put them in outside in unconditioned garages in the north. And they say exactly what you said, Tristan, that with the 240-volt models, if the heat pump isn't capable of working because it's too cold, it'll switch to electric resistance. And, I think the thing is that, at least my opinion about that is, if every once in a while your water heater has to go into electric resistance mode because you've got a house full of kids who came home from a soccer match and all need to take a shower or something, like whatever it is, or you're in a cold place like that where, for every once in a while the heat pump isn't able to keep up and it goes into electric resistance. I don't think that's a big deal, because you're overall going to most likely end up way, way better off in terms of cost of operation than any of these other technologies. But it is true that you should try to get it to operate in heat pump only mode as much as possible, because that's where you're going to see the biggest savings. Yeah.
And I think I geek out a lot on water heaters. I think the ambient range is, I think it's 37 degrees, that's the low, to 120 degrees.
That sounds right to
All
me.
below that. And that's true, unless you have a cold climate heat pump, that's true. That's where the frost forms, and so the heat pump can't operate below that. But again, then it goes into electric resistance, as Brian
Yep.
and Tristan were saying.
I mean, Tristan, we kind of glossed over the brand differences, but do you have a point of view about that? I mean, I wanted to ask you about that. I mean, is there certain brands that you think are worth, or the rise to the top somehow at the moment in terms of what's out there?
Yeah, so our preference at Barnett is Bradford White. That partially just has to do with the fact that they're more contractor friendly. So I don't even, as far as I understand, I don't think, unless you're a contractor, that you can buy a Bradford White heat pump. And part of the reason for that is you get much quicker help and turnaround on if you ever have warranty issues or things like that. They also have the Top Connect, which I know Rheem is just coming out with their Top Connect now. But for a while that made installations much easier. I will say though, when it comes, we have part of the tech program in California was that it needed to be Wi-Fi connectable. And the Rheems are much better on that front in terms of being their usability and ability to connect to the Wi-Fi. And really, there's not a huge difference between the two in terms of reliability. We just prefer the process with Bradford White.
Maybe
Yeah, that's fair.
example
Say a
of-
little bit more about the Wi-Fi then. Why was that a requirement?
In our territories, the utility companies had to set up time of use schedules. So basically the rates are higher between say 4 and 9 p.m. Or some other time frame. And so the water heaters would automatically switch to vacation mode during that time, so that then they weren't using that energy, and it would help actually lower the homeowner's bills as well.
That's great. Yeah. That's a
Water
cool
heaters
feature.
do have, yeah, they seem to be very shiftable. People can turn them off during those peak times and people
Yeah.
never notice the difference because they store so much energy.
I mean, I have found just that Wi-Fi smart thing is pretty useful. Like when you go for a vacation, you're, oh shoot, I forgot to turn the water heater off. You can just do it on your phone. It's really nice.
You can see energy usage on the apps. I think most of the models have some pretty cool apps.
Yeah, our homeowners love it.
Nice. We are getting some questions on split units. I don't know, Tristan, if you all have installed any split heat pump water heaters. To my knowledge, the only one currently on the market is the Eco 2 system that we showed in our water heaters, but there are new manufacturers getting into the game. Brian and I are going to be talking with the manufacturer EmberTech, which makes a split unit tomorrow in heat pump water heater day. But yeah, talk to us about, do you have any experience with split units where the compressors outside and the tank is inside?
Yeah, a very limited amount, but yeah, we installed one or two. I mean, realistically, like my understanding is a split unit is everything you wanted a heat pump to be. Even their cooling system is, if I remember right, CO2 rather than I forget actually what the other one is, but anyways, they're super efficient. They actually have a lower operating temperature as well. And so they really are like, if you have a large home, that would be kind of the route to go in terms of making sure that you have plenty of hot water all the time and running it just with the heat pump.
They're typically more expensive, I would assume, to install and
Yes,
everything. Yeah.
that is the drawback, is they are quite a bit more expensive.
Mm.
I think what we see is that there are lots of, for example, the Northwest Energy Efficiency Alliance now has a hot water innovation prize to get a split unit that's affordable. So I think in the next 5 to 10 years, we'll see manufacturers bring their split. They exist in Asia, they exist in Europe, and
Right.
they'll bring them to the US to give us more product options. And
Yeah,
I
there's
guess,
a question here about noise too, and I guess the split, would that be another advantage to the split one, is the noise is outside the house, right, not
Yeah,
inside.
exactly. It'd just be like having your air conditioning outside the home running.
Mm, right.
how about someone's asking just about location, and you mentioned this before, whether you can locate a water heater outdoors. In California, that seems to happen a decent amount. Any drawbacks if it's an outdoor closet, your water heater, to putting a heat pump water heater in?
It's really just making sure you have enough airflow if it's in a closet. Besides that, I mean, just make sure it's a hybrid in that case, just in case. We did have one homeowner where he was concerned because we had a cold snap, and for a couple days it was going into the hybrid or the electric resistance mode, and he just wanted to know why. But just to make sure that you're aware of that. But they work very well outside. We even did a little bit of innovation creating our own outside closets using enclosures. And so, yeah, it's something that we do often.
Hey, we should talk a little bit about 120 volt models. We haven't talked a bunch about that yet. So are you installing many of those, Tristan?
Yeah, we install a lot of them. They're a great option for homeowners.
What is it? Tell us a scenario that kind of triggers going that way.
Yeah, there's a few. One would be if, say you have a 40-gallon gas water heater that is, or actually a better scenario is, say you have a gas water heater that has direct or power venting. Usually the cost to replace that is almost exactly the same, if not a little bit more, than switching to a 120 volt heat pump water heater. And because the venting on those has an outlet, there's already a plug there to plug right into. So that's like the best case scenario. We also use them with older homes where a panel upgrade would be required for a 240 volt. So that way we can save the homeowner money and just use an existing circuit in the garage or in the home, and just maybe all we'd have to do is run an outlet closer, but you do have a 10-foot cord with 120 volts. So most of the time we can just plug it right into an existing outlet.
Yeah, that's great.
And then we're getting a couple questions just asking us to talk about noise a little bit. I know we've touched on it briefly, Tristan, but where have you seen noise become an issue for homeowners? Like, yeah, is there a location? Is it, is there a model or brand? Where is noise an issue from heat pump water heaters for homeowners?
Yeah, it's really only an issue if it's butted up against, say, a bedroom wall. And even in that case, it really depends on the homeowner and on the home itself. We've had plenty that go up against the wall of a bedroom and there's no issues because maybe the insulation's better, the homeowner doesn't mind it. They're not super loud or anything. I usually equate it to what it sounds like to have your air conditioning unit run outside, maybe even a bit quieter. It also depends on the model. I don't remember off the top of my head. I think it might be A.O. Smith that says they have the quietest heat pump on the market. But again, they're usually pretty similar across the board, and they're not like crazy loud or anything. They're just, some people don't like the added noise within their living space.
It seems like there was a period where there was a run, there was a model, a version. I think it was one of the Reams and some of the early models that when these were first coming out, they had some vibration stuff. So it was a
Oh, yeah.
combination of noise and vibration. But it feels like they've kind of remedied that. That's the impression I'm getting, because I just don't hear about it that much anymore. Is that what you're seeing?
Yeah, it's definitely tapered off. I agree with that. It's not really a big issue. We just like to make sure our homeowners
Yeah.
are aware of that before we move forward. And we install sound dampening or vibration dampening blocks at every point of contact as well. So usually that also is
Mm.
more than enough to stop there from being any issues.
Yeah. One question I have for you is that a lot of these, at least the ones that I'm familiar with, they'll have modes. They have different modes of operation. So there'll be hybrid mode or energy saver mode or heat pump only mode. And it can be confusing, I think, for people to know what to do with that. What do you recommend people do in terms of which mode to select?
Well, when first installing it, we usually like to have our homeowners try out heat pump only mode, just because that's the most efficient. That's what you got a heat pump for. And if for any reason you notice like, oh, like after the fifth kid takes a shower, I start to notice it gets cold, then you can switch it to say energy saver mode, where it still prioritizes the heat pump, but if needed, it'll kick in the heating elements. And if we're running a test or something, we might kick it into electric only mode, but we never have the homeowners leave it on that, because otherwise could have just gotten an electric resistance water heater.
Yeah.
Yeah, that seems to be my experience, Brian's experience, run it in heat pump mode. Maybe there's a certain times of years where you want to take it out, or if you have a larger house or a lot more flowers, yeah.
Yeah, like maybe, it's the holidays and you got a lot of people visiting, put it in one of those other modes, but most of the time, yeah.
Yeah, exactly.
Right.
There's a good question here from Gary about how do you calculate the extra heat load that these can add to that a furnace might, because it's basically cooling your home somewhat.
Mhm.
It could potentially add heating load to your home. In the summer, you're getting air conditioning out of it, so that's a benefit. But in the winter, do you have a point of view about that, or a way to talk to customers about that?
Not necessarily, and the reason is because usually we're installing these actually in unconditioned spaces. They're usually not affecting the heat load on the home, the interior at all. And when we do install them indoors, we do ducting, so it's blowing the cold air out somewhere else. So it's not usually an issue that we run into.
Yeah.
Yeah, I mean, you have to think, like, if you're right, installing them in your garage, that's an unconditioned space. Your basement, semi-conditioned, you've got that's below ground level, so you're getting that, kind of free 55-degree temperature all the time. I can speak personally, from our now exhausting it into our home, it's pretty minimal. I think we do hear this a lot, but it's you're going to have a big load on your heating system, but I think that's more of a myth. It's not that much.
Yeah. I mean, you think about nobody really worries about that with their refrigerators,
Right.
but that's probably more of a concern, to be honest, because that's your living space, your kitchen, but it's just not a lot of heat that's being, moved one way or another.
Yeah. I think maybe as we're wrapping up, Tristan, do you have any top tips for folks who are calling a contractor? What should they ask for when they're getting their heat pump water heater bid?
Yeah, the two main things I would ask for are, one, are they going to pull a permit? We've seen unpermitted heat pump installs, and they are rough. You definitely, when a contractor's pulling a permit, they're going to do quality work, because then, they know the city's going to come out, be inspecting it, make sure everything's up to code. And at least in this time, they know that they're probably going to get calls from the inspectors, because these are still fairly new to the market. And so a lot of building departments aren't familiar. And so the contractor has to be prepped and ready to answer why everything's running the way it is, and what even is the heat pump water heater. So it kind of shows that there's a lot of quality and a lot of expertise with heat pumps when the permit's already a part of the installation. One other thing is just to make sure that especially, or if you're going with a 240-volt model, that your contractor is going to do a load calculation. You want to make sure that you're not overloading your panel with it. We have seen where, a homeowner just kind of had somebody install a heat pump or did it themselves, and now their panel needs to be upgraded because that's the only way that they're not going to keep tripping the breaker. And so those two things are the main things I would say to keep an eye out for and ask for when shopping around for contractors.
Yeah, that sounds good. And then of course, make sure that they've installed a bunch of these already.
Yeah, yeah.
That's a good one too. But and the other thing, I don't know, we see in a lot of places, just in terms of advice to you out there who might be looking at these, a lot of times it's the HVAC installers who are the first to embrace this technology and do water heating installs, as opposed to the local plumbers. That's often the case. We've seen that in a couple of places. I think as they're becoming more familiar, that's going to change, and you'll see, plumbers embracing this just like everyone else. But in some of the early adopters from the installer side were actually HVAC contractors, the people who are putting in your space heating solution. So that's something to look at.
Well, Tristan, thanks a lot. I think you've summed it up for me. This has been fantastic. Thanks for sharing your experience on 240 volts, 120 volts, different locations, and yeah, really appreciate the time and expertise. Yeah, Brian, anything else to add?
No, I don't think so. This has been great. And Tristan, really appreciate your time and expertise here. I think all of you out there will agree we had the right person to ask these questions to, someone who's installed a lot of them. So thank you, Tristan. Thank you all who tuned in today, and we'll be sending recording and all the presentation materials out to everyone. And yeah, good luck with all your electrification projects. Be sure to get in touch with us if you have questions that didn't get answered. We'll try to make sure that we can find an answer for you.
Great. Thanks so much, y'all. We'll talk to y'all soon.
Bye-bye.